In Lesson 4, we'll be covering multiplication and division, understanding that those are inverse operations just like addition and subtraction are, and then we'll be doing some multiplication and division patterns similar to the addition and subtraction pattern problems we did in Lesson 3. Now multiplication, it's basically shorthand for addition. For example, if I had 6 and I wanted to add that 3 times, 6 plus 6 plus 6, that is equal to 18. We can also write 6 3 times by saying 6 and the little x, which is our times or multiplication symbol. 6 times 3 equals 18. Sometimes a dot is also used, like 6 dot 3. That also equals 18. And parentheses, if there's no number or no plus or minus sign between the 6 and the 3, then that means you're doing multiplication. So that means 6 times 3 is 18. Some important words to remember are the numbers that are multiplied together, those are called the factors, and then the result of multiplication is called the product. And those are real important things, the results of these different operations, the name of them. The result of addition is called the sum. The result of subtraction is called the difference. The result of multiplication, that's called the product. Let's go ahead and do some multiplication problems. I'm going to assume that you know how to do multiplication already, so I'll go fairly quickly through this, but I will review a little bit. 478 times 119, we'd want to rewrite that vertically, and it doesn't matter which number we put on top. We could put the 119 on top or the 478. It does not matter. And if you remember, when you do multiplication, that number on the bottom, you just multiply place by place. Take the 9 and multiply it by the 8, the 7, and the 4. So basically you're saying 9 times 478. Then you do the 1 times 478. Then you do the other 1 times 478. And so really what you're doing is you're saying 478 times 9 plus, put parentheses around that, 10, right? Because that 1 after the 9, that's in the tens place. 10 times 478, and then plus 100 times 478. So that's another way to think about that. You take each place, multiply its value by the other number, and add them all together. So we'll start with 9 times 478, and let's work on that. 8 times 9 is 72. We put a 2 down here, bring a 7 up to the top. 7 times 9 is 63, plus 7 would be a 70. So we put a 0 here and a 7 up here. 4 times 9 is 36, plus 7 would be 43. So we have 4,302. That's what 478 times 9 equals. Now we go to the tens place and we say 1 times 8, that would equal 8, and we write that number in the tens column. We use our first result as a guide to where to put the 8. We don't put it in the ones column because it's really 80. We're saying 10 times 8 is 80. So it goes in the tens column. Then we do 1 times 7, 1 times 4. Next, we go to that third one. It will start in the hundreds column. 1 times 8 is 8, and so it goes here. Then we do 1 times 7 is 7. 1 times 4 is 4. Finally, we add those together. Just like I have over there on the left, we would add 478 times 9, which is at 4,302. We add that to each of the other parts, and I'll have to do that over to the right because I'm running out of room at the bottom. And so that first column just has a 2 in it. So we'll put a 2 down. The second column is 0 plus 8, which would just be 8. The next column is 3 and 7 is 10, plus 8 is 18. So we have an 8, and we carry a 1 over. 1 and 4 is 5, plus 4 is 9, plus 7 is 16. So we put a 6 down, carry the 1 over. 4 and 1 is 5. 56,882, and we can put a comma in there. That's our product of that multiplication problem. Let's do another one. This one deals with money, multiplying 200 by $3.75. In a problem like this, we'll just rewrite it vertically. Doesn't matter which number we put on top. I'll put the 375 on bottom. And we don't worry about the decimal place until the end of the problem. Then we go back and we put 2 decimal places in. So we take it out and then we'll put it back in later. So 200 times 375, and we just go ahead and do our multiplication. We'll be doing 5 times 200, so we'll have 0, 0, 10. Then we do 7 times 200. Remember, we put that 7 times 0, 0. We'll put that one in the tens place because now we're working with the tens place in 375. 0, 0, 21, or not 21. 2 times 7 is 14. I was thinking 3 times 7. Now we'll do the 3, and we would start in the hundreds place, 0, 0, 6. So now let's add these together, 0, 0, 0, 5, 7. 75,000. But we put our decimal point back in, and it would go right here. And that's our answer. And we can put a money symbol at the front, or a dollar sign at the front. $750. That's what 200 times 375 is equal to. Don't forget that when you're multiplying with decimal numbers. You don't worry about the decimals until the end, and then you just add them back in. Part B of this lesson is on division, and it's like the inverse of multiplication. Let's say we had this, 6 divided by 2. We'd be thinking of how many equal groups of 2 could we divide 6 up into. And we know that we could have 2 plus 2 plus 2 equals 6. I shouldn't put an equal sign over there. Let me scratch that out, because 6 divided by 2 doesn't equal 2 plus 2 plus 2. But it does mean that we would break 6 into 3 equal groups of 2. 2 and 2 and 2. So 6 divided by 2, that equals 3. Same idea works for fractions. If we had 4 divided by 1/2, how many groups of half could we split 4 up into? Well, if we thought of each of these blocks as counting as 1, 1, 2, 3, 4, if we split each one of those into half of what they originally were, that would be 8 halves. So 4 divided by half equals 8. Now, just like multiplication, addition, and subtraction, there are special names for each part of those operations, and here we have special names as well. The number you're dividing by, that's called the divisor, and then the other number is the dividend. The result of division is always called the quotient. So we have the result of addition is the sum, the result of subtraction is the difference, the result of multiplication is the product, the result of division is the quotient. Let's go ahead and do some practice problems. Look at practice problem C. What I want you to do on this is not use like standard division format to solve this, but I want you to just think about groups here. And remember, your divisor, you think of that as your groups. How many groups of 1/4 could you split 1/2 into? And let's just use a box, and let's say that box is equal to 1/2. Now if we split that into 2, each one of those would equal 1/4, right? Because 1/4 is plus 1/4 is equal to 1/2. So we can split 1/2 into 2 equal groups of 1/4. That means that 1/4 divided by, 1/2 divided by 1/4 equals a positive 2. And that would be our answer. The quotient, that means how many groups can you divide a certain number into. How many groups of 1/4 can we divide 1/2 into? Well, we can divide it into 2 equal groups of 1/4. Let's do another problem. 267 divided by 12. Now this one I want you to use standard division format to solve this. This one, it's just a little more complicated to think of how many groups of 12 could we split 267 into, and so we use our long division format. We put the divisor on the outside and we have this division symbol, and we put 267, our dividend, inside that. And we think of how many times 12 can go into that number. First, we just look at the 2. Can 12 go into 2? No. 12 times no whole number equals 2. 12 can go into 26 2 times, because 12 times 2 is 24. And so we write the 24 down here, do subtraction, and we end up with 2. Then we bring down the 7. And then we think 12 can go into 27 how many times? Well, it can go into that 2 again. 12 times 2 is 24. 12 times 3 is 36, so that's too big. We're always trying to find a little bit smaller or equal number than that 27. So 12 goes into 2, or 12 times 2 is 24. Subtract again, and we get 3. And we don't have any other digits left in our dividend, and so we write that as the remainder. We just say R3. 22, remainder 3. If we want to think about our place value in this problem, what we were really saying to start with, instead of 12 goes into 26, we were saying 12 goes into 260 20 times. And so that first 2, it's in the tens place, or it has a value of 20. And we're really doing 267 minus 240 equals 27. But it's just shorthand. We don't worry about that 0. We just say 12 into 26 2 times, and then we get 24. 12 times 2 is 24. Subtract 24 from 26, we get 2. Then we bring down that 7, because we're really doing 267 minus 240. Just in our head we think of 26 minus 24, because that's just simpler to work with. That equals 2. Then bring down the 7, because 267 minus 240 equals 27. This step-by-step process of completing a division problem, that's called an algorithm. That's just a step-by-step process, is what an algorithm is. Let's do a division problem dealing with money now. $65.70 divided by 30. So we just think 30 goes into 65 how many times? And that would be 2, because 30 times 2 is 60. So we put 60 down here and subtract. We get 5. We bring down the 7. We don't worry about the decimal place there, but we do put the decimal point in our quotient. So we say 2 point, so we'll know that after that will be decimal values. And we think 30 goes into 57 how many times? Well, that would just be 1 time. And we would have 30 times 1 is 30. 2, 7, 27 is our answer. We do the subtraction there. Bring down that last 0 on the end. Now we need to say 30 goes into 270 how many times? Well, just forget the zeros for a second and think to yourself, well, 3 into 27. 3 times 9 equals 27. So 30 times 9 would equal 270. And so that's what it would be in our quotient, is a 9. 30 times 9 is 270. Our remainder is 0. And so there's our answer, $2.19. We could split $65.70 into 30 equal groups of $2.19. Do not use a calculator to do these problems. You could use a calculator to check your work. You could do 65.70 divided by 30 on your calculator and see what you get. The purpose of these problems is to make sure you understand the steps in the division algorithm. Let's look at the last part of this lesson on multiplication and division patterns. Now, we just did in lesson 3 addition and subtraction patterns, and we started that by discussing addition and subtraction as inverse operations. In the same way, multiplication and division, those are inverse operations. Like if we had 3 times 2 equals 6, we could get back to that 3 by doing a division. We could say 6 divided by 2 equals 3. So that's what we mean by inverse operations. One undoes the other one. 3 times 2 equals 6. If we want to get back to the 3 with those numbers that we have there, 6 divided by 2 gets us back to a 3. or 6 divided by 3 would get us back to a 2. Let's go ahead and do some practice problems. Look at F. F times 20 equals 30. We have a missing value in there, and so we just think of our patterns here. We know that division undoes multiplication, and these are like those addition and subtraction pattern problems where we had 2 known parts and 1 missing part. We work with those known parts to figure out the missing. And we wouldn't do 300 times 20 because we know that that times 20 would not equal 300. We'd do 300 divided by 20. So division undoes multiplication. And we'll say 300 divided by 20. We'll use our long division algorithm format. Remember, an algorithm, that's just a word that means a step-by-step process. And we'll start with 20. That goes into 300 one time. So we'll put a 20 here, subtract, and we would get 10. Bring down the 0. 20 goes into 100 exactly 5 times. And so we'll have 100 here. Subtract, we get 0. And F equals 15. And so on these type of problems where we're finding a missing number, we can always check our work by substituting back into the original problem 20 times 15, and we can work this. 0 times 5 is 0, and then we'll have 10 there, 0 here, 2 here. That would add up to 300. That lets us know that F equals 15 is the correct answer. Look at practice problem G. G divided by 4 equals 19. So we want to figure out what G is equal to. Usually that dividend is bigger than the divisor, so we would know that would make sense to multiply 4 times 19 to get G. And let's go ahead and do that. 4 times 19. I'll put the bigger number on top here. And we'll do 9 times 4 is 36, so we'll have a 6 down here, carry a 3. 4 times 1 is 4 plus 3 is 7. 19 times 4 is 76. And so we're going to say that G is equal to 76. We can check our work. 4 into 76. Do long division format here. 4 goes into 7 one time. So we'll have a 4 here. Subtract. That would give us 3 and a 6. 4 goes into 36 exactly 9 times. And so that is correct. G does equal 76. Let's do one more. 282 divided by H equals 47. Now this time it's kind of like G. It's a division problem, except the missing number is the divisor now, and that's usually the smaller number. And we know we wouldn't take 282 and multiply it by 47 to get H. So that's a hint that division is what we'll need to do to solve this. We'll need to do 282 divided by 47 to figure out what H is, not 282 times 47. So just keep that in mind. When the divisor is missing, you're going to be doing a division problem always on these missing number problems. So let's go ahead and do that. 47, we make that the divisor, and 282 remains as the dividend. And so we'll say 47, that goes into 28, doesn't go into 28, so we need to think 47 into 282. Here's a good time to do some rounding. Just round 47 up to 50, and that's an easier number to work with. 50 goes into 280, or about 300. It would go into that about 6 times, because 50 times 6 is 300. So 47, let's just see what 47 times 6 is. We could do that multiplication over to the side. 7 times 6 is 42. Bring a 4 up here. 4 times 6 is 24 plus 4. That's exactly 282. So 47 goes into 282 6 times. And so that's our answer. H equals 6. We've already checked our work because we did that 47 times 6 over to the side, so we know that that is the correct answer. 282 divided by 6 equals 47. So on these multiplication division pattern problems, when you're finding a missing number, you just have to recognize that pattern there. When the divisor is missing, you're going to divide the two numbers that you have, the bigger one divided by the smaller one. When the dividend is the missing number, it's usually the bigger number, so you're doing multiplication to get your result. Okay, well that's all for lesson 4.